Okay. Assalamualaikum warahmatullahi wabarakatuh. Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Right, so we start a bit late today because I need to send my kid to school. Of course, with all the dramas before that. Okay. Okay, let me present my screen now. Right. Before that, as you are aware, today we'll be having our second quiz, right? Second quiz. So this one is on pneumatics. So as we agreed upon in the last class, I think we'll do this starting from 5 p.m. to 9 or something, 9 p.m. 5 to 9. All right. But this one is a very easy one. Okay. It's like maybe a normal quiz. Okay. By the way, I've just seen your quizzes for quiz one. Looks like one student is didn't submit the quiz, but I'm not sure who. All right, so make sure you always follow our class in the group. Okay, all the information is in the group. Right, I might not post the announcement in the Aitalim because we have a quicker and better platform, which is WhatsApp, right? But I always try to synchronize between those two. Okay. All right. So I think we stop here. All right. So hopefully you are clear and understand our previous class. So in pneumatics, I think we started with the method on how to design the circuit. All right, so the principle is always from bottom to top. All right, and then we also talk about how to give the designation of the ports. All right, of the ports and all the valves, the switches and the actuators. All right, and then we move to the logic valve. All right, the valve that can give us the logic. So we looked into dual pressure and shuttle valve. All right, and then we move on to I think memory function. All right, memory function. So this one is DCV, memory function, and then we move to quick exhaust valve. Okay, quick exhaust valve. Right, so you need to make sure you know what is the function of each, and also how it works. Okay, and how to use it in applications. Okay. Okay, today inshallah we'll continue with pressure dependent control. Okay, or sometimes we call it pressure sequence control, whatever you want to name it. All right. Okay, let's assume we have this kind of application. All right, so a plastic component is embossed using a die driven by a double acting cylinder. All right, this one. All right, double acting here. The die is to advance and emboss the plastic when a push button is operated. Okay. The return of the die is to be effected when a preset pressure is reached. Okay, so it will go down, and then when it hit onto the plastic. Okay, so it will build some pressure. So okay, so the double acting cylinder will return when some preset pressure is reached, right? So the pressure will build, and then after some threshold pressure, all right, when this one is exceed, then the double active cylinder will return. Okay, and then the embossing pressure is to be adjustable. Okay, so you can adjust the pressure that you want. Okay, all right, so let's see how this one works. Okay, sorry, I need to admit your friends. Okay, so let's see, we have this kind of circuit. All right, so this is the pressure valve, right? Pressure dependent control valve, right? Or so we call it pressure sequence control valve. Okay, so how this one works? All right, if you see here, I think you can already imagine the working principle. All right, so of course we will start with the source, right? Compressed air, all right, which will give us compressed air to our system. All right, so this compressed air will go to our push button 1S and also our DCV, as well as our pressure dependent control valve. Okay, so when this one is going here, when you push, all right, so you will have the flow from 1 to 2. All right, 1 to 2 here will activate port 14 or port 14, and then port 14, this one will go here and extend. Okay, extend. Okay, extend, and this one will build some pressure. All right, and then you see here you have this pressure meter, right? 1 ZAC is the pressure meter. Okay, so this one you give the designation after the source. All right, so if you give the your power source as 0 ZAC, all right, then you give your pressure meter as 1 ZAC. All right, okay, this one is also called manometer, if I'm not mistaken. All right, pressure meter 1 ZAC. All right, so when this one reach your preset pressure, okay, maybe 5 bar, 6 bar or something. Right, when this one is met, this will give a signal to port 1 2 here. Okay, port 1 2, meaning that this one will give this regulated pressure the airflow, and then this one will will activate this valve. Okay, when this one activates, this position will be used. All right, so therefore you have the source from port 1 to port 2. All right, and then port 2 goes to our port 1 2 of our DCV here. Right, right, so when this DCV, when port 1 2 of this DCV is activated, okay, so normally, so this one will be selected, and this one will retract. Okay, so this one will go to atmosphere via port number 5. Okay, all right, so you press the push button, extend. All right, and then it will move to advanced position, and then after some preset pressure, this will activate the pressure dependent control valve, and then this one, when this one is activated, port 1 2 is activated. All right, and then we'll retract the cylinder. Okay, you got it? So keen to admit your friends again. Okay, all right, so okay, so let's see for the second example. All right, Chelsea, so I have requested to join the class. So I've already give you in. All right, so let's see the second example. Right, a plastic component. This one is similar to before, but I think we have other tasks that you need to solve. A plastic component is embossed using a die powered by a double acting cylinder. The return of the die is to be effected when the cylinder rod has fully extended. Okay, the return of the die when fully extended to the embossing position and the preset pressure is reached. Okay, so before this we only have one condition, right? So before this we have the condition of this one, the preset pressure is reached. All right, so right now you have two conditions. So the return of the die is to be effected when the cylinder rod has fully extended. Okay, so you need to check the full extension of the cylinder. A roller lever valve is to be used to confirm full extension. All right, so the signal for retracting must only be generated when the piston rod has reached the embossing position. Okay, the pressure in the piston chamber is indicated by a pressure gauge, right? So this is the pressure meter that we see just now, okay, or manometer, right? Manometer. Okay, so uh, can you tell me what do we need to add here?
An end valve.
Okay, and so this I think end with the pressure, right? The
Yeah.
pressure dependent control valve, and with
Yeah.
what?
And with the what do you call it? Roller lever switch.
Roller lever switch, right? Okay. Anything else we need to add? Okay, so let's see here. So I will start with listing what component you need. Okay. All right. Roller lever to detect full extension. Okay. All right. Hey. Okay. So you can see here like this, right? So uh, like Intias mentioned just now, you can do like this, or you can end this with the pressure, right? So this one is, similar to N because it is in the serial, right? Serial. So you can either do this or you can add N valve, okay, where the input to the N is 1S2 and this one, the port 2 of 1V1, right? So this one is easy. So when this one is pressed, you have the pressure going, the air going to port number 14. All right, when this one activates, this one will, move this cylinder to advanced position. And then when this one reach the full extension, this one will trigger 1S2. All right, 1S2, and then 1S2 here will be triggered, okay, and then we'll allow the compressed air to go from 1 to 2, okay, and give the power, the source to our pressure dependent control valve, okay, and then this one will will function like the in previous questions. All right, similar. All right.
I have a question here.
Yep.
Can you go to the slide?
Yes,
Here.
question.
Suppose even though the 1S2 is triggered, can you hear me?
Okay. Yeah.
Even with
Your voice is not very clear. Sometimes there, sometimes lost.
okay, okay. So give me a second.
Yeah, no, okay, I think. Yeah, you can continue.
Can you hear me now?
Still a bit, on and off, but you can continue, please.
Okay. So the thing is,
Okay,
suppose my preset pressure is lower than the full extension. This one, yeah, 1Z1
okay,
is
okay.
lower than the pressure we need
All right.
to reach full station.
Okay.
Sorry, what do you call it? Full extension.
Full
Suppose I,
extension.
Yeah, suppose I have reached full extension and I have triggered 1s2.
Okay.
Okay. So when I trigger 1s2, even though it will like start the flow of
Okay.
um
1s2.
yeah, yeah, it start the flow of 1s2, but it won't affect the retracing because at first we need to trigger 1 ZAC1 to
Okay.
make this switch on
Yep.
the pressure valve. So basically, even though the 1s2 is triggered, nothing will happen if my pressure is not optimized here.
Exactly. Exactly. So this one means that even though this one is in full extension, this one will not directly retracted
Unless the pressure is
until,
raised.
yeah, unless this pressure is met.
Yes.
All right. So you need to check this full extension and also the preset value. All right. So if the threshold pressure is not met, this one won't retract directly. Okay. So it will wait until the pressure builds up. Okay. Until the preset value is met, then this one will start to function.
Okay, sir.
Okay.
Yes.
So all right. Any other question? So all right. So let's see this in our simulator here. So this one I just built just now. So hopefully this one works. Okay. All right. So this one I put it differently. So you can see that you can play around with this thing. Depending on your application. All right. So because if you see in the slide, or you go to maybe in internet and books, right? So there are not much examples of pneumatics circuit. So uh, this because it will depend on your application. All right. So different application will give different design of your pneumatics. All right. So okay. All right. So let's see this example in our simulator here. All right. Uh, okay. So this one is our pressure dependent control valve. All right. So instead of only one cylinder, I put two cylinders. All right. So you can have two cylinders, three cylinders, and more than that as well. All right. Okay. Even this one DCV can control different cylinders. All right. So maybe you want to control simultaneously. All right. So you want to control the uh, two cylinders simultaneously. So you can give the same output here to another cylinder. Okay. All right. So pardon me for this. I think this wrong label. Okay. So this one for this. Okay. Right. So how this one works? All right. So let's see. So if this one is triggered, you will extend this cylinder. All right. So still remember this. Okay. So this one is what we call it one-way flow valve, right? So this one will control the speed of our extension, okay, and retraction. So we have both at both sides. All right. So when this one is when this one extends, up to the full extension 1s2, okay, this one will be triggered. Okay, the one at the bottom here will be triggered. Okay, and then this one will extend the second cylinder, right? So this one is 2A. Okay, the second cylinder, right? When this one extend and then go to full extension, this one will trigger 1s3 here, 1s3. Okay, uh, and this one will go to retraction. All right. So when one S3 is triggered, you have signal at this side, and this will make the cylinder retracts. Okay, as well as this one when the pressure builds up to the preset value. All right, this will be this pressure dependent control will be triggered. Okay, therefore this one will give a signal to port 12. Okay, and then this one will retract. Okay, so you see uh, the automation there. All right, so this one extend, full extension will trigger this, and this one will extend. When the second cylinder full extension, it will directly go to the retraction. All right, and then when the pressure is met, this one will retract. Okay, and then this one you can play around with the pressure. Okay, this one. All right, so you can, okay, let's check the pressure here first. I think 6, right? 6 bar, right? So let's say we want to this one to build up the pressure up to the same as our pressure source. Okay, so when this one is met, 6 bar. Okay, so this one will be triggered, right? So maybe we put a bit less, so maybe 5.8 bar. All right, let's check this one. Okay, display, admit. Okay, lines through connection. Doesn't matter, I think. There has been warning, start simulation. Yes. Okay, push button, go to extend, full extension, this one will be triggered. Okay, all right, you can see this one goes directly because this pressure is met. Okay, let's put 6 maybe, so that it will wait a little longer. Okay, push button, extend, full extension, this one will be triggered. Okay, look, right? So you can see the pressure builds up in through this manometer. All right, once again. All right, pressure builds up to 6, and then this one will retract.
Sir.
Okay, yep.
So can you put 7?
Where? This here.
Yeah, yeah,
Okay, so let's put more than 6, right?
yeah.
More than 6. Okay, play. All right. Okay, so you can see that this one won't activate because the pressure is not met, right? Because the this one can only goes to the equilibrium, right? So it will follow the source. Okay, so this one we put 7 just now, so this one won't be triggered. Okay, so this one you can play around. So I think you can see pressure dependent control valve. Okay, pneumatics. It's I want to see the physical one. What's the physical? I think we saw just now. Here. So the is something like this. So you can play around with the with the flow, all right? How many you want to give, you want to allow, okay? Because it's a valve, so you can always control the flow there, okay? So in this simulator we can put something like this, right? So 5 something, right? The same as this one. This one also have this valve, right? So this one is one way flow, okay? One way flow control valve. Similar, so you have the same this type of valve, right? So you can control the flow, okay? All right, so any other question before you go to timer dependent? Right, so let me check. All right, okay, so that's for the pressure dependent control. Okay, now we go to the next one, which is the time delay, or we call it time dependent control, okay? Let's assume we have this type of application. A double acting cylinder is used to press together glued components. This one is glued, and then you want to press, right? Upon operation of a push button, the clamping cylinder extends, okay? Once the fully advanced position is reached, the cylinder is to remain for a time of t equal to 6 seconds, okay? When it's full extension, 6 seconds, and then retract, all right? And then immediately retract to the initial position. The cylinder retraction is to be adjustable, right? So this one you need to put the one-way flow valve, all right? Retraction is to be adjusted. A new start cycle is only possible after the cylinder has fully retracted, right? So this one is also important. So you need to check also the fully retraction, all right? Fully retraction. Okay, so let's go to the next slide. All right, so this is the one way that you can solve the question. All right, so sorry. So this one you have you need to check the full extension and full retraction. Okay, so how this one works, simple. So this one you can see that 1S2 is already be triggered. Why? Because this one is in fully retraction in the initial condition. All right, so you need to make sure that if you put the fully retraction here, you need to make sure you add this one, right, to indicate that this one is already triggered at the beginning. Okay, so when you press this push button 1S1, so the dual pressure will be activated and allow the flow to port number 14. So this port number 14 activates, will extend this cylinder, right? When this one extends, 1S3 will, when fully extension, 1S3 will be triggered. Okay, the roller lever 1S3 triggered. This one will start this time dependent control valve. Okay, and how this one works, you can see that this one go to the port number 12 of this valve, time dependent control, right? And you can see there's also one way flow valve in our time delay valve, right? Here, so this one acts similar like this, right? So it will only allow in this direction, and you can control the flow rate of the pressure compressed air. Okay, so this one goes here, goes into our, this one is the reservoir. All right, so it will fill the reservoir first. All right, when the reservoir is full, okay, and then this will trigger a signal here to this port. All right, So when this one is triggered, this position will be used, right? So now it will allow the compressed air to flow from 1 to 2, all right? And then we'll trigger this port 1, 2 here, okay? Port 1, 2 will make this one go to retraction, okay? Go to retraction and then move up to the full retraction. 1S2 will be triggered again. So this one again, and then if you want to start, you can press the push button again and start all the way again. Okay, so this one is quite simple as well. Similar concept to the pressure dependent. So if the pressure, you check the pressure here, right? So as for the timer, you don't need to do that. Okay, so but you can control the flow rate. Okay, so this one will determine how many seconds that you can delay. Okay, because when this one let's say you give a high flow rate here, so this reservoir will be filled faster. Okay, when this one faster, you don't have much delay here. So if you give only a very small flow rate of pressured air here, so this one will fill the reservoir rather slowly, all right? So that you can have more delay using this valve. Okay, so you also have this in your lab 2 actually, right? So those if you want to try, you can go to your lab. You can go to the lab, or you can ask me, right? So exactly, you will have this type of ports. So you have port 12, port 1, 3, and 2. Okay, of course 3 you don't need to do anything, because this one will will exhaust the pressure to atmosphere. All right. Okay, any question on this? Okay, so I think this one is quite simple. This is the explanation of the one that I already explained. Okay, let's go to the second example. Okay, all right. A double acting cylinder is used to press together glued components. Same application, right? But different tasks. All right. Upon operation of a push button, the clamping cylinder slowly advance. Okay. Once the fully extended position is reached, the cylinder is to remain for 6 seconds and immediately track to the initial position. A new start cycle is only possible after the cylinder has fully retracted. Okay, this one up until this one is same, right? And after a delay of 5 seconds. Okay, so this is the addition. So not only this one need to be in full retraction to start a new cycle, but you also need to wait for 5 seconds. All right, only after that you can start a new cycle. You can press the push button and new cycle will start. During this delay, the finished part is manually removed and replaced with new parts following. Okay, so the second delay here, just to give some time for the operator to remove the piece, the workpiece, and replace with new parts for gluing, right? And then transfer the new one. The retracting speed should be fast but adjustable. All right, the retracting speed should be fast but adjustable. All right, so I think you need to adjust in both ways. Okay, let's see here. Okay, right now instead of one, you need two time dependent control, right? uh, to be used at the full extension and full retraction now. Okay, so where do you want to put here the second one? All right, so I think this one is same, but you need to decide where you want to put the second one. Okay. All right, so because the task is you need to wait for 5 seconds when it reached full retraction. So just put your time delay here, the new time delay after the full retraction has been detected. Okay, all right. So otherwise, other things are the same. Okay, similar to the previous one. Just we add this. Okay, right? Or maybe this one can also be put here. Oh no, only here, only here. So if you put here, you press and then it won't start immediately. All right, it will start after some 5-6 seconds, right? Okay. Otherwise, other things are the same. Okay.
Sir.
Yep. You have questions?
Yes, sir. Sir, why can't we put it on 1s1? What's the difference between these two?
Oh yeah. So for if you put 1v1 here here, so instead of you can only start after 5 seconds, right? This one, if you put here, it means that after you push, it won't start immediately, right? If you press the push button, it will wait for 5 seconds, and then it will start. All right.
And if we
So
put it on 1s2, what will happen?
if you put here 1s2 is the you detect the full retraction, right?
So
So
it's not the full, right? It's the immediate, like it's the preliminary point. So it will be always be triggered 1s2.
not exactly. So because if the cylinder goes to the extend position, this one won't be triggered. This one won't be triggered. So when it returns to the full retraction, then this one will be triggered 1s2.
Oh, okay,
Okay.
sir. Yeah.
All right. So when it retracts to the full retraction, this one will be triggered and we'll start our time delay here. Right. Start time delay. Therefore, when this one back to the full retraction, if you push 1s1, nothing will happen because this one won't start. All right. One won't be activated. Right. Because it will start. Will wait for 5 seconds. Okay. And then this one will receive signal. Okay.
Yeah, get it, sir.
All right. Any other questions? Let me check. There's a new message here. We need to hold the 1s1 for the whole process. Okay. Not exactly. All right. So we because this one is push button. Push button is acts as push button. So you push once and you release. Okay. Why do we need to hold the 1s1? I don't think we will need to hold 1s1 because when this one is triggered, even once, okay, this dual pressure will be activated and will give signal to port number 14. Okay, port number 14. Therefore, this one will extend our cylinder. Okay, if you hold this one for the whole time, when this one is running. Okay, I ask you now, what will happen if you hold this? You hold 1s1, when this one is still running. Okay, what will happen?
Extend and retract.
Nothing, right?
Yeah, nothing happen. Okay, nothing happen because this one. Okay, let me put some pointer. All right, so when this one you trigger here, okay, because this one is already in retracted. So this one is activated, right? 1S2 is activated. So you have signal in both direction. Okay. So this one, port number 14 will be activated. Okay. So this one will extend. When this one will extends, 1S2 is no longer be triggered. Okay. So you don't have any more signal here. Right? Therefore, this one does not function. Okay. This one is not function anymore. All right. So this one extend up to 1S3, 1S3 and some delay. This one will be triggered, right? And then retract. Okay. Retract. So even if you hold for the whole cycle, it won't give any any function to this. Okay. Because you don't have the signal at the other end. Okay. Otherwise, if you don't have this, okay, if you don't have this, let's say this one directly connected to our port 14 here. All right. Okay. And then you choose to hold this one all the time, right? What will happen?
The cylinder keep extend.
Yep, exactly. So the cylinder keep extend. Why? Because port number 14 always receive signal, right? Port number 14 always receive signal, meaning that this position will always be activated, right? So this one will always extend, even you give signal at port 12 here, right? You see, if it is in full extension, 1S3 is triggered. Okay, therefore it will give signal to port 12, but it won't retract because port number 14 still there. Okay, still be triggered. So you need to clear the signal at port number 14 first by releasing this push button. All right, then this one will go to retraction. Okay, so this is very important as well to see in your design. Okay, any more question? Okay, let's see if you can do this in your simulator here to see, moving things. Okay, otherwise you cannot imagine. All right, so let's say I put this way, right? Is this similar to this or similar to the first one? Right, so all right, okay, so when you press the 1S1 push button, extend, okay, go to full extension, 1S2 will be triggered and start the time delay. Right after time delay finish, port 1 2 will be triggered and go to retraction. Okay, so let's make it slower. Okay, see more clearly. Okay, start, go to advanced. Oh, too slow. Too slow. Okay, too slow. 40 lah. Okay, go to the full extension 1S2. This one will be triggered. Trigger timer, and then after some time we will go to retraction. Okay, so the timer you can also control. Okay, so let's see this one. Okay, go to full extension. Okay, wait for a little longer. Right, when this one finish, this one will go to retraction. Okay, that's for time delay. So up until now we have covered the pressure dependent control and also time dependent control, right? So you have two of those. Okay, and then yeah, so you in pneumatics you can also have multiple actuators, coordinated motion. So this one I've already show you in the example of pressure dependent control. So instead of only one cylinder, you can have more than one. So for example, this one you have two, right? Two cylinders are used to transfer parts from a magazine onto a chute. When a push button is pressed, the first cylinder extend, okay, pushing the part from the magazine and positions it in preparation for transfer by the second cylinder onto the outfit. Once the part is transferred, the first cylinder retracts, followed by the second. Okay, so this one push this thing to this place, right? And then cylinder 2A will push it towards this box, all right? And then once the part is transferred, okay, the first cylinder retracts. So this one retract first, and then followed by the second one. Okay, so it's like a coordinated motion. Okay, so one will only be move after the other one. All right, so you can see here the example. Okay, so this one push button. So this one you can see that now it is end with 2s1, right? Where's 2s1? Here. Okay, 2s1 again. Two s1 here is to detect the full retraction, right? So you need this one, right, to detect the full retraction, to show that it is already triggered in your initial position. Okay, so when this one is in full retraction, you push this one s1. This one will be extend. Okay, 1A will be extend, and then up to the full extension, trigger 1s3 here. 1s3 will make the second cylinder extend. All right, go to full extension, 2s2. This one will retract. All right, this one will retract. Okay, when this one goes to the full retraction, this one will retract the second one again. Okay, so you can see the flow there. So extend, full extension, this one will extend. Okay, and the second cylinder full extension, the first one will retract. Okay, first one will retract, and when this one is full retraction, will retract the second cylinder. Okay, not very difficult to see, right? But you need to this one of course needs full focus of you. Okay, so you need to make sure the level is right, all right, and also the flow is right. Okay, so meaning that when what to trigger first before the cylinder goes into extension and so on. Okay. Okay, this one is the explanation. Okay, all right, so that's the end of the pneumatics. Okay, end of pneumatics. So okay, my question. Okay, do you before that, do you have any question on the on our class today? Okay, let's say instead of using this time dependent control of using the pneumatics valve, okay, all right, we want to give the timer using our PLC. All right, we want to use our PLC timer. Okay, how do you do that? Any suggestion?
Sir, can you repeat it?
Okay, so before this we control the retraction using this time dependent control valve of pneumatics, right? So we use the pressure from pneumatics. Okay, we use the switch from pneumatics. So instead of that, we want to give the delay here using PLC, using timer of PLC. How to do that? Okay, how to do that? So you can, so this one you can change, instead of this one will be actuated pneumatically, so you can change to here. All right, okay, you can change that one using solenoid. All right, solenoid here. All right, so this one you can give label. All right, so solenoid normally put start with Y. Okay, Y1 for example. Right, of course this one you need to connect with your PLC input, PLC input or output, PLC output pin. All right, so you connect this to your PLC output pin. For example, O00, for example. All right, so you connect this to O00, and then you can always control that with timer. All right, so let's see your Logix Pro. Okay, so right, so for example, you have this one and your output here. So because you have connected your this solenoid here to the output pin of O00, so you just call this O00. Oops. Let me use the IO simulator. Easy. Okay, let's say it is connected to O20. Okay, because this simulator doesn't have O00, so O20. Okay, so and then and then this one you can trigger using the push button. So maybe you choose this. Okay, I10. Okay, of course this one, this physical switch push button, you need to you need to connect to the pin of your PLC, which is I10. Okay, otherwise for this you need to connect to your pin O20. Okay, all right, so okay, so because you want to add the timer, so you just add timer here. All right, like this. So this one maybe you want to put here. Okay, let's say timer, still remember timer T4. Okay, let's say T4 2. Okay, preset maybe 50 for 5 seconds. Right, and then you put a input here. Okay, of this, maybe this one after 5 seconds, done, you will trigger this output. Okay, all right, of course Logix Pro and Fluid Sim you cannot connect together, but you can if you want, if there's a question like this, you need to put like this, and of course your ladder diagram like this. Okay, All right. And of course, this one you can also put your change to solenoid as well to control the extension. Okay, so so this one you can add one more switch. Okay, of course other switch. Okay, use other switch. Okay, so like that. And actually you can always see, you know, you can simulate the ladder diagram in this fluid sim as well, but of course you don't have the timer, counter and so on. Okay, because of the limitation of your software here. Okay, so for example you can put here, right? So let's say this one, you can put the switch. Okay, switch here. So oh, okay, and then maybe put some output relay here. And okay, so maybe this one you give the same name as this, right? Maybe this one is y2, y2. Okay, let's try maybe duplicated. I think you need to put some other output here. Okay, as the solenoid. Because this one is relay, not solenoid. So is there any solenoid here? This one, you have solenoid. Valve solenoid. Let's say 1y2. Okay. Open connection. Where's the open connection? Okay. So if you limit switch, I think you need to change this one to something. Push button. You have push button there. Okay. Okay. Let's try this. Okay. Yeah, you can see. So when you start this, Y2 is triggered. Okay. You can see that this position is used now. Okay. Of course, in this simulator, you can directly control Y1 there. So see again. So if you push this, for example, this one in your ladder diagram, okay, you will go to extension. Okay, all right. So that's how you relate PLC and pneumatics. Okay. Of course, here you can only play around with the simple ladder diagram because you don't have the timer of the PLC. Okay. Right. So any other question? Already 9:52. Okay.
Sir,
Yep.
are we going to cover this in our finals, like the relationship between PLC and pneumatics?
Yes, of course. So if you see here, the only way to link the PLC is the solenoid, right?
Yes, sir.
So
Yes.
so instead of you have the port 1.4 and port 1.2, right, which will receive the pneumatic signal. So now you will receive the electric signal from the PLC using solenoid, right? Okay. So any other question? So I was going to discuss about our quiz, but it's already 9:52. So maybe I just share to you the solution. Okay. So you can study by yourself afterwards. Okay. Because it's already 9:53. Because some of you have classes at 10, right? But by the way, don't forget our quiz at 5 today, inshallah. Quiz 2. So inshallah, in this semester we'll have some 4 quizzes. Okay, 4 quizzes. And then in the next class we will have we will start looking into, I think, CNC. Okay, so you have CNC, and then layout, and also the SCADA. Okay, SCADA and IoT. All right, I'm not sure if we can cover all of those. Hopefully we can cover. Okay. All right, so any other question? Maybe one or two more question.
So are we done with pneumatics? Like completed?
Yep, complete.
Okay, sir.
We're finished. Okay. So Muhammad Azhar, are you clear now how to set the timer? Because I didn't realize you asked the timer. Ask about the timer. Okay, Muhammad Azhar, are you there? Are you okay? Okay. Can you show one more time? So which one? You want to see the how to use timer, how to set timer using pneumatics or using PLC? Pneumatic. Okay, pneumatic. All right. So okay, so this one, I think you guys let's go to previous one. Okay. All right. This one. Okay. So if you can see here in our simulator, you have two types of time dependent. So you have this one, which is normally closed, the one that we use here, and also in the slide, right? Still remember what is normally closed, right? Normally closed, meaning that this port one is closed at the initial, so you don't have the source. So this one won't start at the beginning, and you also have this normally open. So normally open meaning that port one is open, so you have the flow of compressed air in the beginning. All right, directly. So this one will directly start your timer. Okay. So let's say we have this one that we use here. Okay. So this one is just act like a normal timer, so it will give some delay. All right. So this one, how this one works. So if you press this push button, this one will extend. Okay, the cylinder 1A will extend, and then extend up until the full extension. Okay, and then we'll trigger 1S2. Where is 1S2? Here. Okay, 1S2 is a roller lever limit switch. Okay, 1S2 limit switch will be triggered. This one, when this one is triggered, it will trigger the port 12 of this time dependent control valve. Okay, therefore this one will start the delay, right? So this one you can set 5-6 second. Okay, and then when the delay is finished, all right, so this one will give signal to port 12. Okay, right? So when the delay is finished, this you can see here, this valve here will be used. Okay, so you will have the flow from 1 to 2, okay, and we'll trigger port number 12. Port number 12 will make this, when this one is triggered, will make the cylinder to go to retraction. Okay. Okay. So you need to make sure that you understand the principle, and inshallah, in the design part, you will not have any problem. Okay. So do you need to memorize the, how to draw this one? No. So this one you can always refer. So if there's any question on this, you will be given this figure. Okay. So in the past semesters, even I have give this one, student won't draw this one carefully. Okay. Always have some mistake, right? Even I have given the exact figure. Okay. So make sure you just need to understand the principle. Okay. Don't worry too much on the how to draw, right? Just worry on understanding the working principle of each of the item here, right? How the valve works and so on. Okay. All right. So I think with this one, I think that's the end of our class, inshallah. So if you have any question, again, you can ask me at any time in the group or personally. Inshallah, if time permits, I will directly give you the solution. If I don't know the solution, I will, guide you to how to find the solution, inshallah.
Sir,
Yep.
sir, about lab 2, when is the submission for your automation lab report?
Or lab 2, because we just have the manual yesterday, so I will post the manual today. So for the IA lab, is quite difficult to to give you the hands-on things, because some of you for example, for someone who is not in our class, okay, they might not have the experience using Logix Pro. Okay, so that's the thing. So I think we just give you some assignment on handwritten assignment. So I'll post it today, and you can submit next week, inshallah.
So can you extend it, the deadline? Next week is like really compact for us.
No, this one is very easy.
Very easy. Okay,
Yeah,
then
very easy
fine.
one. Yeah,
If
it's
you
like a basic that I've already shown in our classes.
okay, sir. Okay.
Okay, so any more question? I think with that, can we end our class today, inshallah?
Yes, inshallah.
All right, so let's end our class today with tasbih kafarah. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.